Hello guys, in this video tutorial I would like to explain uh, the decomposition of a time series in R. You know that a time series is normally uh, the components of a time series are trend, seasonal variation, cyclic, and irregular or uh, random variation. So these four components can make a time series. For some maybe three, like um, trend, seasonal, and random. Let's see how we can decompose a time series into this component in R. Uh, Initially, we will have some theoretical description, and then we will move to R, that how we can do that in R. So let's move to the theoretical description. Uh, Time series is I explained this in my previous video, and the description is mentioned. Uh, the link to that video is mentioned in the description of this video. Please, you can watch that. There are two types of time series. One may be additive, that all these component, trend, seasonal, cyclic, and random component are in additive form, or it may be in multiplicative form. If you have multiplicative time series, I mean, if you need a time series model, multiplicative time series model, you can convert that to additive model by taking the log transformation. And one other sign, that if the seasonal component is relative constant over time, then you can use additive model. But if the seasonal component is increasing with the time, then you can use multiplicative model. So keep this point in mind. This is important. Now let's move to the description, that what are the main variation or description in a time series. In a time series, there are four types of variation. Mainly, that is trend. We can sometimes we say um, seasonal variation. The other cyclic changes, and trend, which is sometimes we call secular trend, and random variation. Let's discuss about each of them briefly. These are the components of a time series. Secular trend or long-term variation, slowly increasing or decreasing, whatever. Seasonal variation due to season, and cyclic variation. This is normally in the business data, and random or irregular variations. So let's discuss about each of them. Trend, or the secular trend, or the long-term variation. It is a long-term change. Here we'll take into account the number of observations available and make a subjective assessment of what is a long-term. It represents a very smooth, steady, and gradual movement of a time series in the same direction. To understand the meaning of a long term, consider the climate variable. These variables sometimes exhibit cyclic variation over a very long time period of such as 50 years. If one just had 20 years of data, this long term oscillation would appear to be trend. But if several hundred of years of data are available, then long-term oscillation would be visible. These moments are symmetric in nature, where our moments are broad, steady, showing a slow rise or fall in same direction. Some example of the trends are increasing in price, increase in pollution, an increase in the need for wheat, an increase in the literacy rate, the decrease in the death due to advances in science. Okay, so this means that this is the long term, slowly and gradually change in the particular variable. It may be decreasing or increasing, and they are considering the climate data. So if your long term climate data, you can see this variation is a cyclic variation. But if you have little data, I mean not like 50 years or more 100 years data, then this can be appear as a trend. Seasonal variation is due to season, and or maybe some due to some other reason as well, which is mentioned at the end of this. Many of the time series data exhibit a seasonal variation, which is the annual period, e.g. sales, and temperature readings. Seasonal variation are easy to understand and can be easily measured or removed from the data to give deseasonalized data. Seasonal fluctuation describe an irregular variation with a period of less than a year. This should be less than a year, of course. For example, the cost of various type of fruit and vegetable, clothes, unemployment figures, average daily rainfall, increase in the sale of tea in the winter, increase in the sale of ice cream in the summer, etc. All show seasonal variation. The changes which repeat themselves within a fixed period are also called seasonal variation. For example, traffic on a road in the morning and evening hours, sales at festivals like Eid, etc., increase in the number of passengers at the weekend, etc. Seasonal variation are caused by climate, social customs, religious activities, etc. The main cause of seasonal variation are season, religious festival, and social customs. Okay, so this is sometimes something which is uh, due to some activities like season, religious festival, and social custom, and social religious festivals or social custom, the demand of something increasing, like when Christmas time, there's increasing the demand of different things. And the summer, you can see cold drinks and ice cream demand increases, and in winter, the demand of hot drinks like tea and coffee increasing. So these all are seasonal phenomena. Cyclic changes. Uh, the time series exhibits cyclical variation as a fixed period due to some other physical causes such as daily variation in temperature. Cyclical variation is a non-seasonal component that varies in a recognizable cycle. These variations are considered a more dangerous effect on business and economic activity. Sometimes, sometimes series exhibit oscillation which does not have a fixed period but is predictable to some extent. For example, economic data affected by a business cycle with a period varying between about 5 to 6 years. In weekly or monthly data, the cyclical component may describe any irregular variation, fluctuation in time series data. The cyclical variation is periodic in nature and repeats itself like a business cycle which has four phases: peak, prosperity, a recession, through depression, expansion. So this is something like this, and you can see this usually in the business dataset and maybe in other dataset as well. Irregular variation is something like which is random in phenomena, and you can say that when trend and cyclic variation are removed from a set of time series data, residual left, the irregular variation left, which is called random phenomena. There may be some other phenomena which we cannot measure, like trend, like seasonal, that also affect the time series. So that is called random or irregular phenomena. Okay, so now let's move to R, that how we can decompose a time series into different component. Let's suppose I had data of the river flow uh, from the duration 1961 to 1970. It is not till 2000. It is still 70, but the name of the file is look like this. So let's read this data by reading the dot table, and let's see what I just extract this data, the fourth column, that is my time series data, the river flow at Indus, and I convert it to the time series object as well, applying the function on the fourth column from the X variable. I already explained these things in my previous lecture, so you can watch the previous lecture if you want to know how we can select a specific column from a data set like X here. Okay, so let's choose this data. Let's take this. Okay, so now let's see head. Okay, this is the data, and which is the river flow data and at Indus River. Let's see the length of this. Length is 120 because this data is monthly data, and this is from 1961 to 1970. So this make 120 values. Now let's make this more, to prepare this data for decomposition, we need to write like this. This is earlier time series object, but let's see. This is why frequency is 12 monthly data, and start is from 1961 in January. Okay, okay, this is correct now. And then decompose function is you can use decompose function to decompose this data. You can give multiplicative because I mentioned multiplicative because uh, I thought their decisional component is varying over time. But if you don't mention this, this will just take automatically an editor time series. R is just considered by default. This is automatic. Automatic. This is an additive time series. So you can take care about your data. I'm doing this journal, but you can take care about your data whether it is additive or multiplicative. So let's do like this. Okay, and now decompose. The data is decomposed. Now I'm just wanted to plot D, which is decomposed data is there in D. So there are four graphs. One is observed data, the observed data graphs, and then trend. There is trend. The second graph is trend. The third one is seasonal, and the fourth one is random component, irregular component. So you can see like this. However, if you want to separate these different component from D. D has all these four data sets. You can just extract by substituting like this. TRE, this is just the name for trend. And D is the data which they have the whole data, and then by dollar sign and the trend, which is mentioned here. Just write like this. This will give you separate trend data from D and which is stored in TRE. Just do like this. Run it. This is working now, and now you can plot TRE, which is trend data stored in TRE. Just run this and you will see. Okay, so this is trend data. Similarly, you can separate seasonal data from D by using this command and stored in SEAS. This is working, and now you can plot. This is seasonal. Similarly, you can separate random by using this command. You can plot random. So this is all about this data. You can decompose, you can separately analyze the data. Sometimes you are interested in only trend, so you can separate trend and you can discuss about trend, and you can give some recommendation to policymaker on the basis of the trend, which is normally the slowly and main variation. Maybe sometimes seasonal is very important as well. And now let's have another time series which you can see data from our website. So let's apply the same practice with this data and how we can do. Okay, the data is now reading. So it is okay, the data is read. Now we can prepare this data like this. Again, the same thing. And this is birth data is stored from the website here. So now I'm preparing this data for the decomposition. Birth time series days, which make this time series object. Birth frequency 12. This is monthly data, and start from 1946 to 1st January. And let's do this. And now plot birth. Okay, this is sometimes this is interesting data. The birth. Uh, Maybe you can write LWD equal to 2. So that's look like more interesting and attractive. COL equal to red. Let's make a more beautiful graph. Okay, so this is a look like LWD, not D, not LED, it should be LWD. Yes, this is now looking like this graph. Okay, okay, okay. Now the decomposition command. Birth, birth. compose. I this is just the name. Suppose you can name it differently. Birth compose. That is equal that assign this data is assigned from decompose command is again used on the birth. So you can do like this. Now the data is decomposed and save in births comp. So you can plot this now, and you will see the same four plots which we saw in the river flow data. So again, this is the same. The above one is observed data. The second one is trend. You can see a log slowly, gradually change in the data. The third one is seasonal, and the fourth one is random. You can see in trend the values are higher. This is start. You can see higher values are here until 26, 27, or 28. The values are here. And seasonal, there are very limited changes. It is until 1.02 something like that. And irregular is also very less variation. So mainly it is because of trend. So you need to separate these. Sometimes you need to separate. You are not interested in the other component, particularly in case of birth, maybe and other different type of data sets. So let's separate these component and plot it. So the first one is trend. You can see this is the trend. You can see clearly births. This is the trend and times. Now seasonal. This is seasonal, and you can see there's very small changes in because of the seasonal. So this the maximum is one or little more higher than one. Now you can separate uh, random component. So let's run it again. A random component, and this is a random component for this data, which is very less. Minus 1.5 to 1.5 is the range, but almost this is close, to zero. The average value can be close to zero. So this is all about um, decomposition of a time series, theoretical description, and then how we can do this in RStudio. I hope this help you, and you can do now for our own data that how we can decompose the data and different components, and you can utilize important information for different purposes. Uh, if you like the content, please subscribe the channel and see you in the next video. Ciao.